doing a live webinar. We had our very first in-person dispatches last month in San Diego for Enersolar, and today we're back online. We'll be talking about demystifying commercial scale virtual power plants, or VPPs. How are you doing today, Lucas?
Doing great. Happy to be back on the Zoom platform. We had a great live event in San Diego at Enersolar in February, but really excited for this month's topic.
Yes, and for some of the people that asked, we will be doing another live dispatches later this year. I'll kind of hold off on that for now and talk about our episode. I've been personally interested in virtual power plants for several years, so I'm pretty happy to be talking about this episode. Let's get to it. My name's Robert Cross. I'm the principal of Outfit. I've been in the industry for quite a while, and I've known this guy, Lucas Miller, with Mayfield Renewables for more than a spell too. Lucas, talk to me a little bit about what you do at Mayfield.
Yeah, I'm Lucas Miller, Senior Engineering Consultant at Mayfield Renewables. We are an engineering consultancy, so we develop plan sets, engineering sets, and feasibility studies for mid-market solar and solar plus storage projects. So a lot of microgrids, grid-tied PV, standalone storage, typically in the 200 to 2 megawatt range.
Outfit's a design studio. We bring complex technologies to life, often through animation, film, photography, all that type of fun stuff. Lucas and I occasionally get to work together on very complex topics, not unlike we're talking about today. And our guests, Rachel, why don't you introduce yourself, talk a little bit about Enersponse and your role.
Sure. Hi, Rachel Permut. I am the Chief Business Development Officer here at Enersponse. I have been in the energy industry for over 20 some years. Spent 8 years at Duke Energy, 4 years at Engie. Most of that focused on the customer experience and developing behind the meter assets, and now monetizing those. Looking forward to speaking with you all today.
Thank you, Rachel. And Adam, it's nice to meet you today. Tell me a little bit about Molecule Systems.
Yeah, thanks. Thanks to both you and Outfit and Mayfield. This is an exciting webinar to be a part of. When I first got involved or was interested in getting involved in energy, it was reading an article about the future where every home would be its own little mini power plant. And so that was the very beginning, and it started with a finance company back in 2007, 2008. Then I went into this project development side with another company, did that for several years. And then in 2017, I finally got into more of that IoT tech side of energy. And I'd say the first 5 years in the IoT side was getting a master's degree in everything that didn't work. But you need to go through that to know what does work. So anyway, I'm happy to be here and share what we've learned with you guys.
Before we get into the nuts and bolts, I'm kind of curious, what do each of you hope the audience takes away from our webinar?
Yeah, so I'm hoping they understand a little bit more about the energy markets and how to we can help add value and ROI to their projects.
Yeah, I'd say I'm expecting there's a lot of developers out there, and they likely know a lot about the project development process, but a lot of times that software component can be quite complex and a lot of unknowns and sort of piecemeal. And so hopefully what they see here is an opportunity to really streamline the software side of how they can develop projects that can also monetize the grid side as well as the behind the meter benefit.
Yeah. And then how our partnership together makes it all easier. That's definitely why we're here together.
That's key.
Thank you both. I was joking with Adam because Adam and I have actually known each other for a few years, got introduced through a fellow colleague, Adam Gurza from Way of Energy Toolbase. Adam, before you dive into this slide, I'm pretty excited about virtual power plants. Part of the reason why we talk. Just in summing it up in a sentence or two, why are the commercialization of virtual power plants important with where the grid stands today from your perspective?
You know, it really comes down to grid flexibility. You've got, you know, electrification is pushing a lot of new loads onto the grid, and grid operators that are responsible for managing the grid don't really have a very reliable way of controlling all of them. And so virtual power plants are one way where you can actually connect and control to smaller energy resources like batteries, but get them to work together virtually and act as a power plant. So really what it does is it frees up the grid without having to invest in a lot of more grid scale infrastructure. So you can get there faster, and it also lets individuals participate more in the economics of the opportunity.
It's a great overview. Talk to us a little bit about your company. Obviously, we have this graphic here that I think illustrates the gap, right? Let's get into molecule systems a bit.
Yeah, so you know what's exciting about Molecule, it has a very different business model than you might think. There are other platforms out there that support VPP market connectivity, and usually it's based on an API connection. And that's part of what we have, but Molecule is really, think of it as an end-to-end infrastructure for developing software or applications required in the energy space. So if you're going to build a house, you're going to go to Home Depot, right? If you're going to build software, you could come to Molecule Systems, and rather than having to build from scratch, you can start with proven architectures to get you to where you want to go. And then because we're infrastructure as a service, it allows, this is more of an OEM level or a finance type company or somebody that actually wants to own and operate their own software. They can then customize the Molecule platform around their own needs or develop their own applications utilizing the backend infrastructure. So it just allows them to get to market with new products and services in a fraction of the time without the development risk and at a fraction of the cost. Now, what we've done is taken sort of infrastructure that doesn't really make sense to on the project development side, because what you need is you need a product, right? You need an EMS, and then that EMS has to provision the capabilities that you require to operate your project. So that could be simply just doing the economic optimization of a battery, right? Peak shaving or time of use or whatever it might be, or even resiliency events. But ultimately, you've got to get that project across the finish line and connected to the markets themselves. So in order to do that, you've got an EMS that seamlessly optimizes for both behind the meter as well as the front of the meter side. The other thing is that projects, especially on the commercial side, can throw there's a lot of unique situations where you show up, you're there to commission your system, and you've got something that's just not connected. A fire alarm is not being sent to the fire department. That's where Molecule's infrastructure can come in and cover up gaps that might otherwise happen at the last minute, or you've got to swap out some equipment for other equipment that was actually available. We just make that very, very simple. And that's where we say hardware agnostic here. So we have tools that allow us to integrate. The traditional way of integrating with a battery in the commercial VPP market is via Modbus protocol. It's a local protocol. And so we have a tool that allows us to do that in less than 30 minutes. So you can literally the day of certain projects, we've been integrating, on site. And that's just a capability that certainly differentiates us, but it gives project developers and the engineers supporting them, like Mayfield, the opportunity to select the best-in-class hardware, the best cost, whatever works best, and then allow the software to figure out what it needs to do thereafter.
Adam, part of the focus of dispatches is to talk about emerging technologies. And I'm going to kind of segue this into an audience question from Dan Mentor. He's a senior project manager with Labella. Where are we with VPP? Like, how do we grow and accelerate the adoption of VPP? I'll kind of frame it in two parts. what's the lowest hanging fruit, the market opportunity, and kind of what stands in the way of broader market adoption?
I mean, first you need market drivers, right? So you need to have the economics. It's driven by economics largely. The residential market's been easier to tap into because it can get away with, if you want to call it that, with a lighter weight API or a cloud-based control solution. Commercially, it's a little bit more complex, and so we would advise to use an edge-based or having an actual computer at the site with Molecule running on it that would direct the battery or other loads or other resources behind the meter to do what they need to do to dispatch accordingly. So, in terms of barriers for VPP, I think first it just starts with the economics, and Rachel will get into some of that later. And then having the tech that is really easily accessible. And you've got a lot of platforms that you might have a technology or let's say an OEM that has an inverter. It has an API, but it doesn't have the capability to actually meet the requirements of a VPP program, right? Like maybe there's just too much latency in terms of when it's going to respond or how it's going to respond. And so there's gaps like that I think are going to be addressed sooner than later. And those are also gaps Molecule can help support and fill today. So, I think it starts there, and then just sort of the economics of project economics in general. But in California specifically, when you've got NEM 3, where batteries are involved in pretty much almost every solar project, and you're sizing solar to the battery, exercising that battery now becomes an opportunity, right? So market drivers, I think, are really the most fundamental piece.
Yeah, I like that term, exercising the battery, a lot, Adam. And I think that's something we'll touch on later, is just we have a lot more of these batteries getting deployed, but you can think of them as being underutilized to some extent if they're just there for resiliency. If they're only cycled maybe once a day, there's a lot more value just sitting there in these batteries that we could really squeeze out of them. And I do just a couple more questions for you, Adam, and then we can move on to Rachel and Enersponse. We've got a few terms throughout the slides. I do just want to make sure for our audience, we define a few of them. One being grid edge. So we've used that term a few times by this point. Is that more or less devices kind of at that point of interconnection who are speaking to the broader grid, but also the supply and loads behind it? Is there more to it? How would you define it?
Yeah, so the grid edge in our speak, when we talk about edge control of an EMS, it really talks about where is the computing power happening. When you send a signal to an inverter to say charge or discharge, is it coming from the cloud and therefore dependent on having that cloud connectivity and the Wi-Fi and everything else is in order? Or is it local, right? Where it's hardwired right into the inverter itself, and you've got direct control. And so in the commercial market, we would say you really want to, because it's a high value asset and missing the performance on it is not an option. Think of peak shaving, right? Just in economic optimization. You don't want to be relying on the cloud for that entirely, right? So having that edge reliability is really the difference. So that's how I would describe the grid edge in this context.
Adam, how are you getting, in one regard, project developers or asset owners? What is the knowledge transfer? What does education look like if you're trying to integrate more? How does Molecule help customers?
From a technical integration, you're talking about? From like integrating a device?
Technical, or just better understanding the value proposition?
So, again, it comes down to what's the value of participating in a market event, right? And there are different market types or different types of events in each market. And so it really depends on what's available within the project, what devices, what assets, what resources can we leverage. From a technology perspective, what's really powerful about Molecule, both from an EMS and a VPP perspective, is we're not just controlling a battery, right? We actually have other opportunities. If there are flexible loads that could be HVAC systems, water heaters, EV chargers, other things like that, where if we can turn that down and like reduce that load while also discharging a battery, you can get better economic value out of it, right? And so that's where when you go into a project, even if you're trying to do just peak shaving, right? If you're just leveraging your battery, you've got to size your battery considerably more likely, right? If you don't have any other flexible loads to lean on in the event that you run out of your battery. But a battery is a very expensive resource. And so to really optimize both the sizing of it, you want to ensure that you are, capturing any other resources within the project ecosystem that you can. And those would be loads, right? If you can reduce load, we can then offset the spike on the grid by turning something off or turning a thermostat up, right? So we can bring all of that together into a solution that is going to drive better economic benefit for the customer, but also provide more support to the grid.
Great, and let's lean into this kind of markets and economics for a bit. And I turn it to you here, Rachel. You have a lot of experience on the utility side, some of your professional background prior to Enersponse with companies like Engie, Duke Energy. What are some of the lessons that you've learned from that utility perspective that you've brought to Enersponse with regard to VPPs?
Yeah, one of the experiences I had while at Duke Energy was learning as we were moving from a summer in the Southeast from a summer peaking system to a winter peaking system, the challenges of capacity constraints. And as a project developer with Engie, working on solar storage, microgrid projects, figuring out how to monetize those beyond just peak shaving, there was a gap in the market, right? There have always been aggregators for the last 20, 30 years in the energy space, but Enersponse really wanted to bring technology and automation to help solve some of those challenges. How do we ensure that a utility, when the dispatch hits the button, that the load is going to show up? DR hasn't always had the best track record in terms of delivering on that. How can we help monetize assets beyond just the traditional load management? And so Enersponse was founded over 10 years ago to bring connectivity, software, and automation to dispatch those events, to increase the reliability of what was traditionally called demand response and now has evolved into the virtual power plant space as we've brought in other asset types, including storage and EV charging.
Yeah.
Go ahead. Sorry, go ahead.
No, that's great. I think we'll get into one of those demand response examples in a little bit as well to kind of show how does this integration work? What might the battery be dispatching to? What are the signals the grid is sending? I do want to call out just one more term. Again, we have DERMS listed here, Distributed Energy Resource Management System. Rachel, can you explain to our audience kind of what does that mean and how does it fit into the broader energy transition?
Yeah, I like to talk about our DERMS as a translator. So we take things like dispatches from utilities that have a capacity constraint. We take signals from the wholesale market because of their constraints, or potentially price signals or carbon signals. We take things that are coming in, and then we create a dispatch algorithm based off of, okay, there's a trigger. You've reached this much capacity. You've reached this much a price that is over a certain barrier. Please take an action. On the other side of that, we're translating that into building automation systems, SCADA systems, anything that has ability to control load on the in facility side of the business, including battery energy storage systems, and say, hey, charge, hey, dispatch. And so that is where we are a translator from one set of energy vocabulary into a facilities vocabulary. And that allows us to automate that dispatch, which used to be, hey, I'm going to call the facility and have someone go walk over and take an action. Does that?
Yeah, that makes a ton of sense. And I'm kind of curious, in like recent years with the advent of storage, automation, software, and hardware, I kind of feel like we have the built environment and buildings integrating with project development quite a bit now. So from your perspective, how do we get those two worlds to work better together, right?
Yeah, it is. It's having been on both sides of it is definitely a different area of focus. And a lot of the software that was originally developed for the battery energy storage systems was focused on peak shaving. It kind of originated in different markets. And one of the challenges is that not everywhere in the country has high demand charges, but they do have capacity. A lot of the country is growing and increasing on capacity constraints or localized events. And that's where having something that speaks nationally, that isn't tariff dependent, that is where you're able to just set a threshold and trigger off of, it gives you more flexibility and more ability to monetize.
Well, one other question or kind of comment. This is from Daniel Harp, he's a commercial solar designer from A&R. Can we talk a little bit about the physical components of a typical virtual power plant? Because I think that's the other aspect that we're dealing with all these software tools, the physical versus the hardware and the software.
Yeah, the software is not useful unless it's connected to hardware that can actually take action. So when we normally are talking about in the residential space, and that's one of the reasons why Adam and I were excited to get together, is because when you talk about VPPs traditionally, it tends to be your home hot water heater, your EV charger, and maybe your smart thermostat. In the case of the commercial space, we have a different set of assets that we're talking about on the hardware side. And those are primarily building automation systems, pumps, in the agricultural space. We're talking about large machinery in the industrial space, and then our favorite battery energy storage assets. So that's kind of the array of hardware that we're integrating with. And you're normally talking about an inverter, some level of controls, and what's sometimes missing when a lot of HVAC systems get installed, they don't necessarily get that building automation system or that energy management system. And you need that extra layer of controls to integrate with someone like Enersponse to be able to have another program to run when we let you know that there is something happening.
And on that integration side, I'd open up to both of you within this partnership. So Enersponse molecule, let's say I own an industrial facility. I have maybe let's call it a primitive building automation system. I need to upgrade it to let it coordinate with both the hardware and software to get this into a VPP. Is that something that one or both of your companies can help with?
So on the building automation side, we have many partners that we're already integrated with. So if someone has a question, we are always happy to make referrals to our partners. They go and install and help program that machinery. We never have to go on site. We're a no cost to the customer to integrate with any new systems. That's something that we take on as part of our cost to serve. And so any work that for installation or addition of an EMS would be a project run by the customer. On the battery side, I'll let Adam talk to that.
Yeah, I'd say that we can, if there's a building management system in place, we can integrate with that if needed, if Enersponse is not already integrated, so we can stand in the middle. Or if it does or doesn't, we can also look at directly integrating, and that's usually in the context of battery energy storage. Is we would do a direct integration via Modbus with the inverter or the power conditioning system.
Let's segue a little bit into the market opportunity.
Yeah, so what's happening? Why is this a necessary partnership at this point in time? Why are commercial VPPs growing? And a lot of it has to do with what's happening in the energy markets. I'm going to reference some fun acronyms over to the right. So CAISO is where one of the markets that battery energy storage has been growing, has had the longest track record, and it continues to grow based on the demand charge managements I referenced earlier in peak shaving. But now we're seeing, ERCOT has a $5,000 max charge. We're seeing that get hit. A lot more batteries going in to help manage that pricing. And PJM hit its new record prices for capacity for 25 through 26 year, and we'll see what happens as they try to manage costs in that market. But with all of that increased capacity constraint, with electrification, with manufacturing growth, with EV charging, all of those are adding more stress to the grid and therefore creating more peak events where it would be helpful for demand side to get lowered rather than increasing supply. You can talk about, I think on one of your podcasts, you talk about transmission constraints and the challenges with the interconnection and adding more generation resources. The other side of the equation is where we come in and say, hey, let's reduce demand instead of increase supply. The other thing is storage assets are sitting there 387.60, 365, and how many hours a year are they actually getting used? And we always have to think about discharge cycles and warranties, but there is capacity and economic value that is sitting there that, particularly if you're in a resiliency use case, we can help you monetize and increase your ROI. And finally, as both Adam and I have experienced in different stages of our careers, there isn't a lot of turnkey solutions. It's multiple different providers that may or may not have worked together before. And so this partnership is trying to simplify that relationship so that you can dispatch these assets. You can develop, design, install, and dispatch these assets as easily as possible.
A great overview, Rachel. Thank you. Just out of curiosity, trying to do some forecasting, so to speak. What do you expect to change in the next 3 to 5 years, as an example, as far as the opportunity for VPP from your perspective? Is there a use case? Is there a region? What should our audience pay attention to here?
Yeah, part of this is that one of the challenges for those that are on the developer side that don't necessarily integrate with energy work regularly with the energy markets is how diverse our energy markets are in this country. Hundreds of utilities and the major ISOs each have different dynamics, each have different rules in which you can dispatch and monetize these assets. And so having a partner like Enersponse, where we have a whole energy markets team that is focused on that, will help, because what we see happening is with the increasing in AI and increased computing power for data centers. Not only those are looking for the lowest cost load area, lowest cost priced areas, and what used to be lower price, we now see multiple double-digit CAGRs in terms of prices on the local utility level. So we see we have a utility sales business as well, and so we're engaged with them to help them run and add programs in the C&I space, which will then open more markets for battery energy storage and solar plus storage development.
I just have one follow-up question, and I'll segue to Lucas. Is the acceleration of the opportunity greater than people realize?
I do think so. Yeah, I think the infrastructure to support resi was already relatively there with some of the national solar developers who just added storage, and the policy work that was done in that. I always say, storage is about 8 years behind. Was about 8 years behind solar, and it's really catching up. And now on the resi side with policies with changes in NEM policy. But when I think about C&I, it's been even a little bit slower. But what I really see now is that the pieces of the puzzle are there. The cost of batteries have come down and are expected to continue to decline. Yes, there's the complications, which I'd prefer not to get into today, with tariffs and how that may affect the industry. But for right now, prices are coming down. Expertise is increasing. The workforce is increasing that understands how to develop and install these types of assets, which means that the total system cost comes down. And then because of these capacity constraints and utilities' willingness to pay, the revenue opportunity is increasing. So I do think we're at the start of something exciting.
Yeah, and I think that middle market, quote unquote middle market, the C&I space is where Mayfield prefers to live because of some of that inherent complexity. Systems are just in general more cookie cutter on the residential side. And from an ROI perspective, utility scale systems get a guaranteed rate of return in most cases. Residential systems could take advantage of time of use rates. Someone could just install a residential system for entirely different reasons. It could be ROI independent, just they want to have carbon-free local generation. On the commercial side of things, it's all about ROI. It's all about, numbers, penciling out. And I think this type of value add can really go a long way in making that sales process easier in the CNI space. And I love all the points you just mentioned, Rachel, and wanted to see if there's anything else that you'd add on kind of how the value of a commercial scale system can increase through participation in one of these programs. Like, how could a developer use that in their pitch to a industrial facility or arena?
Yeah, and I think we'll get into this in terms of the case studies as well. But right now, I think this is a revenue stream that is not part of the majority of modeling that I see. Maybe in rare cases where the project is an in-front-of-meter project and you're really focused on market revenue. But on the CNI side, the business case has been built off of things like SGIP and Smart Massachusetts incentive program, and now Con Ed. And then peak shaving. And so this is an additional revenue stream that Enersponse can help developers look at and provide insight into to add to their revenue, to their ROI models.
Actually, I want to squeeze in one more from the audience. Someone just asked, of the regional utilities that we're seeing on the map here, are any of them most attractive economically today, or in the next couple of years, do you see that shifting at all?
Yeah, so PJM is currently, NISO, particularly in Zone J. If you look at the Manhattan area where it's very hard to develop batteries, but from a DR, just a pure market dollars per kW perspective is the most lucrative. PJM is at a peak. So the Mid-Atlantic is looking great if you're in Dominion or Baltimore Gas and Electric territory. Those have particularly strong price signals right now. And then the third I'd pick is CAISO. In terms of consistency of programs, availability, and the value. What's really going to be interesting to watch, though, is MISO and SPP. There's a lot of conversations happening right now in the co-op market around some challenges there, having to meet their growing load demands and within their markets. And then MISO is starting to deliver constraints. If you check out, one of the grid status or one of the market, the difference between MISO North and South, there's that really teeny area of connection between them. There's transmission constraints, and so we're starting to see prices heading north in MISO. One other product I'm going to talk about just really briefly, because I think it's worth it, is transmission constraints and how batteries can help with transmission constraints. And that comes from the utility perspective. And so in areas where there isn't ability to flow energy, we are definitely seeing an increase in those charges being passed on to customers. And so anything you can do to help reduce peak capacity during those events, monthly events, helps the utility and helps keep prices down. So it's almost like, yes, you're saving for today, but you're also helping keep your prices lower for tomorrow.
Just to ask one more question while Lucas segues from Craig McBurney. This is a big one. Is it going to get harder or easier to interconnect?
Are we gonna
feel free to pass if you want?
No, so I'm gonna use my old world expertise on this one. So I think we're going through a rough period. I'm actually pretty optimistic that the pressure on the utilities from the developers and the customers is increasing. I think the tool set for the utilities is going to increase. I think there's going to be increased investment there. So in the short term, it's going to continue to be quite painful, but in the midterm, I do expect to see improvement for interconnection through better modeling and better policy around willingness to take on these assets. Robert, do you agree? Do you disagree, Lucas?
I agree. I mean, I think there's a lot of pressure, quite frankly, and that drives innovation, irrespective of federal issues. Price matters, and as market adoption increases, I think there'll be more standardization over time, in part out of competitiveness.
Yeah, I sure hope it gets easier, and hopefully seeing the value of these types of programs and DIRGE more broadly helps utilities to realize that they are assets for them and might be beneficial to interconnect more rather than fewer. And we've got one example here, I think a really, really impactful, valuable one to run through. This is where we get into kind of how the two companies work together. So how Molecule and Enersponse are coordinating for specific grid events. So I'd kick it off with you, Rachel. Again, just thinking terminology here. Can you walk us through what a demand response event is, what that means from the utility and the end user perspective?
Yeah, so this is where software and communications are so important, and this is where integrations matter and why we wanted to partner with Molecule, because we already have all of the relationships with the utilities, with the ISOs. We even have a partnership with a company called Singularity, where we're bringing in carbon data, carbon intensity of the grid real time, so that we can report on if you want to dispatch because emissions are high. We can dispatch to you based off of that. But most events tend to be, because there's a utility program issue, tends to be based off of weather or a local outage, and then high prices. We bring those in, we translate those, whether with our connectivity through APIs from all of those different providers, and we translate them in our DR business into building automation systems and into those assets. One of the challenges we found in the battery energy storage space is that there's a lot of different inverters, there's a lot of different vendors, and those to integrate with all of those, given the size of the systems, may not always be as cost effective of work as we'd like. And so Molecule was a great partner. And I'll turn it over to Adam to talk about how he works directly with the building, the battery energy systems. But we found that as a great way to make it easier to integrate with all of the battery energy storage systems that are being developed today.
Yeah. So to going left to right here, what would happen is that in the little cloud box there is Molecule would then pick up a signal from Enersponse and process that through our communications framework down to the battery at the edge. And I should also add, our communications framework was developed initially to communicate with the International Space Station, and that's what it still does. So it's a very highly secure connection. And then when it does ping both the edge device that is controlling the inverter, that edge device will store that if it's an event that's happening tomorrow or a couple days out, or even if it's in real time, right? So it'll capture that signal and then dispatch. And then once it dispatches, we also will create a dispatch event report, so we know exactly what happened during the event with the device, and be able to provide that back to both to Enersponse as well as the customer. Yeah, so that would be the sequence of events.
Yeah, and we've gotten a handful of questions in advance on the hardware side, and I know you've mentioned this, that this whole program we're looking at here is hardware agnostic, but I really just want to reinforce that point and see if there's anything more that either of you want to add on the product integration, really more of the how do I get hardware to participate in this? And if there's anything, do I need to look for something on a spec sheet for my inverter that would validate, hey, I can integrate Molecule, I can integrate that EMS?
Yeah, I can start with that. There's nothing really on a spec sheet that you're going to find if we're going to be talking about an inverter here. So if it's a Modbus, any protocol that it has, we can integrate with it. So that is one of our superpowers. And we will also offer, if we're going to bring the EMS to the project, we'll do the integration with the inverter for free. So it's included in the project. So you don't have to worry about that. There's other platforms that could charge 6 figures just to integrate with a battery, right? Which just kills the project economics. Our goal is to not be adding zeros to your project profile. So, but really what it looks like is we have off-the-shelf gateways that we've already ported our software onto, and all that can come in a box with everything else that it needs to work. It would then be installed by the installer. Alternatively, if we're working with somebody that has, let's say it's more of an OEM or a system integrator, if they have a Linux-based computer already, right, that's controlling their project or their system, we can port directly onto it. So we have one partner, RCT Power, where we're actually embedded inside their Windows PC in their cabinet. So there's no additional hardware required to turn on VPP. And then with other partners, it's a very much bolt-on. I would say from a cost perspective, I'm sure people are wondering that. Let's say pencil in on the low end $2,500 for hardware to make sure that you've got the VPP capability. If we're doing EMS, there might be some added requirements there if it's off-grid, especially, but otherwise it's going to be pretty similar in terms of the hardware footprint and cost.
Got it. And I'm really curious, Adam, on the communications side of things, that is one piece of the development puzzle. Mayfield, when we're developing a plan set, we may spec certain hardware, but when we get to the point of EMS, communications design, coordination, typically we hand that off to the EMS provider, and then they come back to us and we integrate it in the rest of the set. We got a question from Bill Althouse here in the audience. Are your companies collaborating with any standards in development? So IEEE 2030.14 being one example, or really any other utility level communications protocols, standards, or updates?
Rachel, you want to go first on your?
Standards are not, we work with Open ADR. That is the primary standard that we work within. It is, but there's not, from the rest of it, we're just we're almost like a communicator. We're not actually controlling anything, so they're not applicable.
Yeah. So there are standards out there that are are well intentioned and designed to simplify this whole sort of mystery in a box that we're dealing with. But what we find is that when you get down to the actual Modbus map of an inverter, even if it is, say, SunSpec compliant, there might be certain registers that are SunSpec and then other ones that have just been sort of, custom. And so you can't really rely on that. It'd be nice if it was just plug and play every time. But again, that's why we developed a no-code tool where literally it's a color by numbers exercise. If you can read a Modbus map, you can even do your own integrations on our platform. We don't have to do it for you. If you can't, we can provide it as a service or include it in the project if we're providing the EMS as well. But yeah, there aren't really standards, I would say, that are followed well enough to where we could say, oh yeah, we can just use this standard. I'll add one more thing. With Molecule, we can use any we can speak via Zigbee, Wi-Fi, Bluetooth, Modbus. So it really doesn't matter any kind of machine communication protocol. We have a library for it. And so think of us as almost a Google translator, right? That sort of sits between the different devices. So we might be orchestrating all of them, but we might be communicating in Zigbee to one, Wi-Fi another, Cloud API to another, and local Modbus for another. And so it's what we call, our EMS is really a hybrid edge cloud solution. So you might have your thermostat that's connected via Cloud API, but everything else is local.
Thank you, Adam. An aspect of dispatch is the energy transition is global. We actually have a healthy international audience. I'm going to kind of pose this question to the group here. This is for João Silva, a consultant from JL Power in Brazil. What are the main characters? What main characteristics must exist in a market to be possible for VPP implementation? He lives in Brazil. They're having a significant expansion of grid-tied residential solar, but a shortage of BESS, or energy storage and electric vehicles. How can VPP get started or grow in a market like that from your perspective?
Yeah, I think there's a couple of different market factors that are worth looking at that make it economic to participate. First is resilience. If your asset is there to provide reliability, that helps make it a lot easier for the rest of the economics to pencil. The second is essentially a differentiated time of use rate. So it's working with the utility and figuring out whether they're willing to pay more during certain times. And so that is a challenge, and definitely, many parts of the country, they still have one charge. So that doesn't really help you with your economic payback there. And that's where demand response can come in. If there's a market signal, if there's a wholesale market or a regional market where they're willing to treat a behind the meter resource with fair and equitable standards to a front of meter large power plant. And that's been some of the innovation that's happened in the US. And we're still looking forward to FERC 2222. Did I get all 4 twos in there? I think I did. Where we're expecting, increased, treatment for behind the meter resources to participate and access those market revenues. So there's kind of those 3 layers of economics that can help provide project viability. That requires having good regulatory relationships, both with the utility as well as the market maker, and having some really technical conversations about reliability, around voltage, all of those kind of conversations, as well as interconnection to the grid itself, and having those rules as clear as possible to allow for that fast integration and timeline to add them. Because even if it pencils on paper, if you can't get it in the ground and operating, all to the, can stymie you.
I can add a little color there. I would say from a sort of a strategic planning perspective, picking hardware that can provide the solution when the market opens up. So if the opportunity in Brazil doesn't exist today, I'm sure it's coming. It's just a matter of time. It's the same way here in the US, where not every market is a great or has a VPP opportunity in it, but it is coming. We're even seeing dynamic tariffs coming here in the United States, where imagine it's every hour that the price is different, and you're having to adapt to it. So it's no longer just about, hey, controlling a battery. It's controlling all of the devices in that ecosystem in a coordinated way. So in Brazil or in any other country that's sort of looking at the future, I would say identify hardware and software partners that have the flexibility to unlock or turn on these capabilities when the market catches up. And I would also say, if you're a developer and you're going to have any sort of ongoing either O&M or involvement in a project, residential or commercial, try to go with an edge-based solution, because virtual power plants and all of this added value that we're talking about, it comes down to how reliable is it as well, right? And so reliability is everything. And if DERs today or batteries today are heavily discounted because they're not reliable. Right. And so you're leaving money on the table. If you have a reliable solution, I would say it's going to be an edge-based solution. And we can talk more about how Molecule can support that in the next slide, but that would be my thought around new markets.
Yeah, and you mentioned it, Adam. So let's talk about it. Let's look at kind of complexities today, some of the challenges today, specifically in the commercial space, and how this type of VPP program and partnership can really help ease those constraints and complexities.
Yeah, I mean, look, from a project development perspective, really what you want to do is reduce risk as much as possible and increase value and maximize value, right? And so what we're talking about here is both of those things. The way we can reduce project risk is by just allowing you, the engineers, and the developer and or the future project owner to really select the best-in-class hardware that they want and they believe in, right? And then design it the way you need to design it, and then just know and have sort of that confidence behind you that no matter how this works out, that you're going to have software that's flexible enough and dynamic enough to be able to make it all work when it comes together at the project. And the other thing is that projects evolve over time, right? You might have something that you're installing today, but the market's ever shifting and ever evolving, and there's electrification of fleets and other things that are happening, right? So you might design a microgrid today, but maybe you're adding all sorts of other new loads and new requirements in the next 3, 5, 10 years, right? And this system is supposed to last that long. So really what Molecule does is says, hey, you start with us at any level, and as new requirements come out or opportunities arise, you can, in our speak, it's just a matter of adding a new app to that device, right? So we can, our platform is a very modern architecture for software, but it's a lot like a smartphone, where if you need to add a new capability to a project, you add a new app to it. You're not just creating this ballooned energy management, sort of solution. because what you find is every project has a nuance or a unique something about it. And to make sure that your software stays lean and reliable, we've got an architecture that allows you to, again, stack these applications. So the project development side, we kind of give you, imagine you've got the freedom to pick any hardware, design it the way you need to design it so that it meets all of the local requirements. And then Molecule comes in with the solution. And that sort of speaks to the energy management component as well. Usually in commercial, that doesn't come with the inverter. In residential, the inverter usually has a timer in it, and it can address time of use rates and other sort of basic energy management of the battery for you. But in commercial, it's a lot of those system integrators don't really want to get involved on peak shaving, right? Or whatever, or the resiliency requirements. And so developers are running around trying to find software that they can now plug into this project. And because software has historically been very custom, and a lot of platforms out there require new custom coding just for your project, right? Again, where Molecule comes in is we have what we call an automation engine, but it allows you to create rules just by dragging and dropping little boxes on a frame. So you can create a sequence of operations in a very simplistic way without having to be a professional software coder, right? Integrate a new device, do whatever you need to do to make sure the project works. And again, we can either train you and your team if you have that level of expertise, or we can provide it as a service to you in the project, right? So that would be on the EMS side. Technical integration, I think we spoke to a little bit earlier, but all of these different devices are going to have a different sort of mapping to them and integration. But the cool thing is once it's integrated, it's part of our library, right? So right now we've got direct Modbus integrations with about almost 24 different inverters out there. But if there's one that's not on the list, we can simply add it to the list and make sure it's ready for your project.
Adam, we have another audience question. Ken Hoffman from ESS. It was good to see you at Intersolar. Can the Molecule Systems Edge EMS aggregate numerous bus units on the site, treat them as a single DC block that the inverter communicates with?
Yeah, so I think what we're talking about there is, let's say you're stacking systems. We had a recent project. It was with using a Synexel inverter, and the integrator that was using Synexel in this project did not have the ability to stack inverters, but the project required it. So Molecule came in and provisioned that capability. So we can bring additional control and expansion of existing systems in that way without necessarily having to have it as a native capability that the manufacturer offers.
I know we've got a few minutes left here. I do want to move us through. We've got a couple example projects here. So a few different utilities that we're working with, a couple of regions around the country. Rachel, I'll turn it to you here to kind of walk us through the examples one by one. But first, I want to start with what we show on the right side of the screen here. Data needed to evaluate economic potential. And your team has put together, frankly, a really short list, right, of here are the inputs that we need to deliver an ROI estimate to you. So if you could kind of explain how you guys established this list and what those inputs are used for.
Yeah, so it is very geographic based. That's why we love our map. We work with over 70 programs, different regions across the country. So we need to know where you are. That will determine what programs are available to you. The second thing is what battery are you installing? And then how are you planning on using it? Are you planning on using it for resiliency? Are you planning on using it for peak shaving? What do you actually have available for us to monetize? There's different ways. If you already know how you want to use it, then then you can let us know what is left available for that battery. Are you doing it 80-20? That's where we're trying to, as most people do, to maintain battery life. Those are kind of the kind of operational constraints we need to understand, so we know really how many kW we're putting into market. And then finally, what size is it? What duration do you really have available? Because some programs are 2-hour programs, some are 6 hours. And so depending on the size of the battery, if you want to provide us, hey, well, we're trying to figure out what size we should make the battery, we can give you kind of that feel as well. What you'll get back from us, depending on the size of the project or the pipeline that you're able to provide us, different splits. So that's how we make our money, is as part of the project revenue cost, we take a portion of that. And that ranges, depending on the market, from 50 to 90% goes to the customer or the developer in this case, and Enersponse, and that is how we make our revenue. So that is what we need and what we'll provide you. And we thought we'd go through a couple of examples just to give you a feel. I picked two of the more lucrative markets where I know battery storage projects are being developed, to kind of run that through with you. So from there, we'll start with California. California grew out of the self-generation incentive program, incentivizing projects in the C&I space. But as that program has declined, folks are looking for other revenue streams. It is a very strong peak charging market, but if you have a resiliency requirement, peak shaving, maybe not the complementary value prop that you're looking for. And in that case, you may be wanting to look at DR and the demand side generation DSGS program. Option 3 was specifically built for batteries in mind to help monetize that. And revenues, depending on duration, another reason we care about duration again, vary gross from $80 to over $100 per kW. And so if you have projects in that market, you're definitely looking at some additional revenue stream to help your ROI on that. From there, we'll go to the second case. So PJM New York is quite different. Here it truly is an economic optimization case because demand charges aren't as high. That peak shaving revenue that you may have been looking at in California looks quite different in these markets. There's a number of programs in New York. There were like 8 of them, so I didn't list them all. Some of them are stackable, some of them aren't. Some of them are fast response, some give you day-ahead notice. And then in PJM, you have your standard capacity program with ELRP. And then, of course, sync reserves that can be a really good fit for battery energy storage systems. And in this case, these programs range for about $100 a kW to $300 a kW, as I was talking about in Zone J in New York. So some real revenue potential here on a kW basis to help for you to think about your projects.
Great. Thank you, Rachel. And I know we're under tight time constraints here. We've got just a minute or two left, so really appreciate running through those quickly. I do want to get us to, we always end with just some key takeaways here. I think the big one is just, this is viable now. Like, I think a lot of people tend to think of VPPs as residential-based assets, whether it's a small battery in a garage or a Nest thermostat, but we can do this at the larger scale, and we can integrate all these units together, even if they are larger than what you might find in a garage. And doing so, we can also maximize profitability. We can use those assets that are otherwise sitting idle, maybe not cycling as often as they could. And also through some of these integrations, we can stay ahead of future changes to those interconnection standards. Like Adam mentioned, maybe our communications protocols change. We can stay ahead of that, stay flexible with this type of integration. Rachel, Adam, I'll open it up to you guys. Anything else to add? Any other keynotes for the audience to take away?
Our goal is to make this as seamless and flexible for you to add revenue streams to your project. So please reach out. I think the next slide has our contact info. I know we're close on time. Thank you.
Yeah.
And go ahead, Adam.
No, I was just going to say thank you to you guys and just let the audience know that we are really, really excited to look at projects. So if you've got projects that even think could participate, bring them over and we'll help you through it and see if there's a there.
Thank you, Adam. Thank you, Rachel. Just want to note we're in process of planning the dispatches for the second half of the year. So if you're a manufacturer, service provider, or project developer, feel free to reach out to Lucas or I as we book the second half of the year. And then Lucas, Mayfield does consulting engineering and education and training. You have a lot of online workshops for battery storage, UL codes and standards. And I think you had a big announcement today, if I'm not mistaken.
Yeah, shameless plug for the Mayfield second annual education summit that'll be held in Seattle, Washington in mid-October. Registration has not opened yet, but you can keep an eye out on our LinkedIn and over email, and we'll share updates over the next couple of weeks. And that'll be 3 full tracks of all-day trainings, everything NABCEP certified, covering codes and standards, energy storage, and microgrid best practices. So we're really excited for October in Seattle and hope to see a few of you in the audience there.
Lucas, Adam, Rachel, it was great dispatches. Have a good day.
Thank you. Thank you, everybody.
Thank you.
Thank you.